Section 3-4, notes number 15, solve equation with variables on both sides of an equal sign. Make sure you put your name, date, and class period, please. And your essential question is, how do you solve an equation with variables on both sides of the equal sign? And to solve an equation with variables on both sides, you must move all variables to the left side and all constants to the right side so you can isolate them. So if I look at our first example here, our first step is to move all variables to the left. Okay, because I want them all on one side. So I'm going to move all the variables to the left. If I'm looking at this problem, I notice right here I have a 4x on the right side of the equal sign. I need to move it to the right side. And to do so, I need to do the opposite. This 4x is a positive 4x, so when I cross the equal sign, changes it to a negative 4x, and I want to line it up underneath the other x that's on the other side, so that now I can combine them. And when I bring it down, I have the 7, but now I need to know what negative 8 and negative 4 combined together actually give me. And I believe that is 12x, and it equals what's left on the other side. Remember to take that subtraction sign with the 17, so I have a negative 17 on the right hand side. So that was your first step in moving the variables. The second step is move constants to the right. And that's just an in general rule of thumb, moving constants to the right. For this one, I have a 7 on the left hand side. I need to move it over here to the 17. The 7 is a positive 7, so when I move it, it changes to a negative 7. And when I bring it down, I have a negative 12x on the left side equals, and then I need to combine negative 17 and a negative 7. I'll put that in my calculator, make sure I don't mess up with my numbers. That gives me negative 24. And then the last step is to do the inverse. Whatever operation you have actually taking place, you need to do the inverse. Since this is a multiplication, because the number and the letter are together, that means my inverse is to divide by negative 12. And that'll give me x equals negative 2 as an answer. Alright, the second example, I want to move the 16 to the right hand side, but I've got this fraction in the way right now, and I want to get rid of that fraction first before I actually move my variables. And like before on our notes, I said a way to get rid of our fraction is to take the denominator and multiply it through on the other side. So I'm going to put that side in parentheses so that I'm going to actually multiply 4 times each item. That means on the right hand side I can ignore it, but my new equation looks in this fashion. So that the fraction that was originally here, I have the numerator with its original spot, but the denominator is on the opposite side. At this point, I still can't move my letters together, so my first step is to distribute the 4 into my parentheses. Remember, to distribute means to multiply. That means I'm going to do 4 times 9, which is 36x, and then 4 times a negative 5, which is a negative 20. On the right hand side, I'm going to distribute the 1 into the parentheses. 1 times 16x is 16x, and then 1 times 60 is still 60. Now I'm able to, since my problem does not have any parentheses or fractions now, I can go to my steps. First thing is move the variables to the left. Well, if I look here, the 16 needs to move over here with the 36. This is a positive 16, so when I move it, it changes it to a negative 16, which is the same thing as subtracting. what is brought down, 36 minus 16 is 20x minus the 20 that was above equals, and bring down the 60 as well. Okay, your next step was move the constants to the right, and my constant is the number all by itself. This one's my constant because it doesn't have the letter. It has a subtract 20, so the inverse is to add 20. And whenever I combine this, the variable with the coefficient here, 20x, just brings down, equals, and then 60 plus 20 is now 80. And my third step is to do the inverse. The inverse of a multiplication, because that's what this is multiplying, is to divide. And the result is x is equal to 4. Alright, if I look at example 3, this one looks pretty basic, but we've got to be careful. My first step, I don't have any parentheses like I did up here, and I do not have any fractions, so I'm ready to go to my first move, which is move the variables to the left. If I look at my variable, I have a 5 on the right hand side. This is a positive 5. So when I move it to the left, it changes it to a negative 5m. I'm going to line it up underneath my other variable, and I want to combine like terms. That gives me 24. Negative 3 and a negative 5 is now negative 8m is equal to, and since these canceled out, what's left over here? Nothing. Nothing's there, so I have to have a 0 as a placeholder. Next step is move the constants to the right. My constant is the 24. The 24 is a positive 24, so when I move it, it changes it to a negative 24. Make sure you go all the way across the equal sign. Bring down your variable. This is a negative 8m equals, and 0 minus 24 is a negative 24. Last step is to do the inverse. Inverse operation is going to be dividing by negative 8. That means m is equal to 3. Alright, on example 4, notice I have this fraction. So I'm going to take the denominator, put the left side in parentheses, and that denominator is going to go out as a coefficient, so that now I can distribute the 3 into the parentheses. 3 times 8y is 24y, and 3 times a negative 6, 3 times 6 is 18, and since the 6 was negative, the 18 is negative. And then on the left hand side I have a 2 in the in the numerator, so I'm going to distribute. 2 times 6y is 12y, and then 2 times 15 is 30, and the 15 was positive, so I'll put a plus 30. Okay, now all fractions and all parentheses are gone. I'm ready to start my steps. Move the variable to the left. Here I have the 12y on the right hand side. I need to move it over here with 24. This is positive, so it changes it to a negative 12y. (24 minus 12 is exactly 12y. Bring down your constant, which is a negative 18, equals, and bring down your other constant, which is a 30. Step 2, move the constant to the right. Your constant is the 18. It's subtracting, so now you're going to add. Bring down your coefficient. 12y equals 30 plus 18 is now 48. Third step is to do the inverse, which that means I'm dividing by 12. And 48 divided by 12 is y equals 4. Okay, if I look at number 5, here's a word problem. It says a car dealership sold 78 new cars and 67 used cars this year. The number of cars sold by the dealership has increased by 6 cars each year. The number of used cars sold has decreased by 4 per year. If this trend continues, how long will it take for the used cars to be twice, the new cars to be twice the number of the used cars? Twice the number of the used cars. Alright, here's a little hint that was given to us. New cars that were sold was 78. Plus, increase in new cars over X years. The new cars increased by 6 each year, so that's going to be my 6x. Equals, and then they have a 2 for the twice, and then they have a parentheses, the old cars, which was 67, plus it says it was decreased. Decreased is a negative. It was decreased by 4 x's. Oops, I got too many parentheses. I got too many parentheses here. By 4x each year. I'll take care of those right now. Here I have 2 signs together. I don't want 2 signs. This is a plus and a minus. So when they're different signs, this entire thing just changes to a subtract sign. That way I only have 1 set of parentheses here. Alright, they want us to find how many years it's going to take for these 2 things to equal each other. So we're going to solve it. We got to get rid of the parentheses, so that means I'm going to distribute the 2. So 2 times 67 is 134 minus 2 times 4x, which is 8x. Alright, all parentheses are gone and fractions are gone. First thing, move variables to the left. My variable is the 8. It's a negative, so it's going to change to a positive 8x. Bring everything else down, so I have a 78 plus 14x is equal to 134. Second step, move constants to the right. My constant is the 78. It's a positive, so when I move it, it becomes negative. That gives me 14x equals, and then 134 minus 78 is 56. Okay, so I'm going to bring that over here. I'm out of space. So I have 14x equals 56. Last step is to do the inverse, which means I'm dividing by 14. Okay, and my answer is a 4, so it'll take 4 years for the number of used cars to equal twice the amount of the new cars being sold. Okay, on the back side we have 2 more examples here. And here we got to be careful. It says solve the equation if possible. When we have the if possible given to us, that means we have answers that could be the identity, and they could be a no solution. And that's the cases that I want to emphasize here to you. We'll have one of these two answers for these questions, and I'll show them to you. If I go about the same process as I did on the front side of the paper, I have to get rid of the parentheses, which means I'm going to distribute 3 times the understood 1 in front of the x. So 3 times 1x, which is 3x, plus 3 times 4, which is 12. Okay, I brought the 3x down from the right-hand side. Our next step was to move variables to the left. So that means I am moving, let me get a different color, the 3x on the right-hand side, which is positive, to the left-hand side, which turns it to a negative. Well, the 1 on the right-hand side goes away, but 3 minus 3, guess what that is? Well, that's 0x equals 12. Can I have 0? No. That's the same thing as 0 is equal to 12, which is not true. That's false. This is not the case. Anytime we have a 0x equals to a number, that's false. It doesn't matter whether it has the x or not. If it's got a 0 coefficient, this is not true, so that means that's the second one. It's a no solution. So if your x's, your variables actually equal each other, it's going to come down to it being a no solution. If I look at the second one, I have the parentheses again, so I'm going to distribute the 2 into the parentheses so that I'll have 2x plus, and 2 times 5 is 10. If I follow my procedures, it said move variables to the left and constants to the right. Here's the variable of a 2x. I'm going to subtract it because it's a positive on the right hand side. If I subtract it, and I subtract it from the other side, my x's go to 0. Okay, and a lot of students will stop right here and say, oh, that's a no solution. The x is 0. I said, but we got to follow through on step number 2 is move constants to the right. If I move the constant to the right, here's the constant of a 10. If I move it to the right, that means I'm going to subtract 10. And what drops down is I have 0x is equal to, well, 10 minus 10 is 0. I have 0 equals 0. And since that's true, this is a true statement. 0 does equal 0. Whether it has an x or not, it's 0. Since it's a true statement, that means it's this first word right here. It is the identity. Okay, that is your solution. Those are your answers. Those are kind of weird, but you got to watch out for them. Identity means it's exactly the same on each side. Notice here it had 2x plus 10. The other side had 2x plus 10. They're exactly the same. On this stage, we had 3x equals 3x plus 12. They are not identical. This one had a plus 12 on the side of it, and that's why it changed and came out to be a no solution. Watch out for those. Alright, here are 4 independent practice problems I want you to work, and we'll check on first class tomorrow. Also, make sure you answer your summary off of the essential question, which was, how do you solve an equation with variables on both sides?